A plane left 30 minutes later than the scheduled time, and in order to reach its destination 1500 kilometers away in time, it has to increase its speed by 250 kilometers per hour from its usual speed. Find its usual speed. So this is the question. So again, this is an application problem related to solving quadratic equation. So the main work in these type of problems will be to make the quadratic equation. After forming the quadratic equation, our work will be very simple. So forming the quadratic equation is the task here. So just look at the question clearly here. We are having a plane, okay? It is traveling with its usual speed. Then it would reach the destination which is 1500 kilometers away in time. Suppose if there is going to be any delay, okay? If it is going to start a 30 minutes late from its usual time, okay? Then in order to reach the destination on time, okay? It has to increase the speed. So the plane is being increased with the speed of 250 km per hour from the usual speed. So it's traveling with a high speed now. Okay, so it's going to reach the destination on time. It is our duty to identify its usual speed. So as we all know, okay, in order to work with such type of problems, we will be working with the formula related to speed, distance and time. Okay, so since we are given with the difference in start of the airplane, that is it's starting a 30 minutes late, that's given. That is when it is traveling with usual speed, there is going to be no change in the time when it's going to start. But if there is going to be a delay, so the difference in time is mentioned here, that is 30 minutes. So with this difference in time, let's identify the time taken by the airplane to reach the destination with usual speed and the time taken by the airplane with high speed. The difference between these two timings is nothing but 30 minutes. Okay, so this is what we get to understand from the question. Let's work with that. Okay, so first thing which we are going to write is time taken by the airplane to reach the destination with usual speed. So the time formula, when the speed and distance are given, it will be distance by speed. So the distance to be covered is 1500 kilometers. So 1500 by the usual speed. We don't know what is the usual speed here. So let's assume it to be some x. So this is 1500 by x hours. Let's assume like that. So this is going to be hours. Okay, right? Next what we are going to write, time taken by the airplane to reach the destination with a higher speed. So what will be the higher speed here? Actual speed is x kilometer per hour. Okay, so it is increasing its speed by 250 kilometers per hour. So the higher speed will be the actual speed plus the increased one. So x plus 250 will be the higher speed. That is the new speed now. So now it's going to be distance by speed again. Same distance with the higher speed, x plus 250 hours. Okay, now it is told that if the airplane is going to start 30 minutes late, okay, so the actual time minus the new time, okay, this is going to be 30 minutes. Okay, since both are in hours, okay, what we are going to do here is we are going to convert 30 minutes also to hours for our convenience. So 1 hour is equal to 60 minutes. So in that case, when we are going to convert minutes to hours, 30 minutes is nothing but half an hour. But anyways, mathematically it is our duty to show it in steps. So 30 by 60 hours, which is nothing but 1 by 2 hour. Okay, let's do that. Difference in time. This is 30 by 60 hours since we have converted minutes to hours here. Okay, that's why. Right. Now next, we'll solve this equation. Okay, again we need to make the denominator same. So we are going to go with cross multiplication method. X plus 250 to this side top, x to that side top. So the common denominator will be x into x plus 250. So common denominator x into x plus 250. What happens here? X plus 250 is multiplied to this side. Numerator x plus 250. Now x to the opposite side, numerator 1500x. This is equal to 1 by 2. Right? Right? Hope you are able to see it now. The common denominator x into x plus 250. Then we have done the cross multiplication. 30 by 60 is simplified as 1 by 2. Right. Now let's apply the distributive law and we'll simplify here. 1500 into x. So this is going to be 1500x. Now 1500 into 250. 15 into 25. 375 and 3 zeros. So this will be plus 375 followed by 3 zeros. 1, 2, 1, 3. Minus 1500x by x into x square, x into 250, 250x, which is equal to 1 by 2. Now plus 1500x and minus 1500x gets cancelled. So next what is pending? We have 3,75,000 by x square plus 250x, which is equal to 1 by 2. So this is like this. 3,75,000 by x square plus 250x, which is equal to 1 by 2. Now 2 will be multiplied with the opposite numerator. X square plus 250x will be multiplied with the opposite numerator. So I am writing it here. So this will become 2 into 3,75,000, which is equal to 1 into x square plus 250x, which is x square plus 250x. That's it. So now 2 into 375, 750 followed by 3 zeros, which is equal to x square plus 250x. Now let's bring all the terms one side. Let's take the 7,50,000 to that side. It goes as minus. So this will be x square plus 250x minus 7,50,000, which is equal to 0. Let's solve this. So let's do the factorization here. We want minus 7,50,000 as the product of two integers and plus 250 as the sum of two integers. So it is easily understood to identify here. It is a multiple of 10 actually. So let's check out with easy multiplication. We want 7,50,000 as a product, 250 as the sum. So it will be easy if we take 1000 and 750. 1000 into 750, 7,50,000. And 1000 and 750, when we subtract, we get 250. Since we need minus 7,50,000, okay, we need to check out for which number we need to give the negative sign. Since this is plus 250, okay, when we are doing addition, okay, if the two numbers are with different sign, we will be giving the greater number sign to the answer. So the greater number should be positive. If 1000 is positive, then only when we subtract, okay, we will get plus 250. So 1000 into minus 750 is minus 7,50,000. 1000 plus of minus 750 will be 250. So we have got the factors. So this will be x plus 1000 into x minus 750, which is equal to 0. Okay. From this, we can understand x is equal to minus 1000 and x is equal to plus 750. Okay. Plus 1000 comes to this side, minus 1000. Minus 750 comes to that side, plus 750. So speed being negative is not possible. Okay. So this is not possible because we cannot have a negative speed. Okay. So x is equal to plus 750 is the only possibility. So the usual speed is 750 kilometer per hour. Okay. So usual speed of the airplane is equal to 750 kilometer per hour. Okay. Now, few of them might have a doubt. If not, also just please listen to this. That is, you might have a doubt. That is, actually, the plane is starting 30 minutes late. In order to reach the destination on time, only it's increasing the speed. So, it must have reached the destination on time, right? So, that will be few of the children's doubt. Let me say you, they are actually increasing the speed and they are trying to reach the destination on time. But we don't know whether they reached the destination on time or not. Okay, so that is why we are identifying the difference in time and we are equating it with 30 minutes. Okay, suppose if the flight has to be started by some 10 in the morning, okay, but if it is going to start by 10:30, since because of this delay it has to reach the destination on time, for this what they are doing is they are increasing the speed of the airplane, and because of which they are assuming that they might reach the destination on time. Okay, anyways, there is a difference in time since there is a delay in the start of the airplane. We don't know whether they reach the destination on time or not, and that is why we are identifying the time with usual speed and the time with the higher speed. We are subtracting both in order to say there is a difference in time and we are equating it with 30 minutes. And because of this, we get out the solution. That's it. Okay. Thank you.